Hello, my purpose of making these videos and posting on the YouTube is to see if I can present the subject in a clear way so that it improves understanding of the subject by the students. And these videos I am generally making after seeing what is available on YouTube and try to present the material in a different way and make an effort to present it in a way which is more clear, and the student will be able to appreciate the physics behind the approach to the solution. So the solution for constrained motion problems are discussed in several places, but still seems to be some difficulty to understand. So it's for that reason that I selected three problems and I discuss here the solution to these problems so that the concept of the approach to solving the problems is clear. So the first problem that I take is the problem of you have a surface and you have a box or a bead, whatever it is, then you're pulling or a pulley like this. Now the question is how these two velocities are related. So if this is VA and this is VB, then generally the approach which is taken is VB is VA cos theta. This is, suppose if this is theta, VB is VA cos theta. Not VA is VB cos theta, which is generally, as the students feel, this is the answer, but the correct answer is this, and the students raise a question as to why this is not correct, and some explanation is given, which is not clear to me. So I will try to show that using this standard approach, that is, I would like to clarify this point. Suppose if you take, what is the problem here is, suppose we take y and x, this is r, then x is r cos theta, okay, then we will have dx by dt is equal to dr by dt cos theta, which is Vx is equal to V cos theta. This is what intuitively the students expect the solution, but instead the solution presented is this, and they say that we have take the projection of A on that. Somehow I feel this is not the correct argument, because here we can see the angle theta is varying. It is not constant. Here theta is constant. Here it is varying. So I will try to show that using this approach, we will get this answer. So let us take this to be r, and this is x. So x is r cos theta. Now dx by dt is dr by dt cos theta minus r sin theta d theta by dt. Now we know that sin theta is equal to h over r. This is h, which is constant. So we can write h is equal to sin theta and r. So when we differentiate this, we get 0 is equal to cos theta d theta by dt. Sin theta is h over r. Yeah, we get theta is equal to 0 is equal to Sine theta, this is cos theta, d theta d r. Then we get plus dr by dt sine theta. This gives us r d theta by dt. See, look at this expression, r d theta by dt. So r d theta by dt is equal to, what do we get? We get, this becomes minus, then dr by dt, then we get tan theta. So this is a very important result. Now use this in this expression. We plug in for r d theta by dt, we plug in this value, and this gives us dx by dt. Dx by dt, now we can say it is nothing but, let us see what we are calling it. We are calling it a, right? Dx by dt is Va is equal to, here we have dr by dt, which is Vb. Then we have cos theta. Then we have here this minus and this becomes plus. Plus we have sine theta and tan theta. And here we have Vb. So this we can see gives us Va is equal to Vb by cos theta. This is cos square theta plus sine square theta. This is 1. So this gives us straight away Vb is equal to Va cos theta. So this is the important result which you get by following the proper procedure. This is the correct procedure, but instead I am not quite sure whether the argument which is given by the other authors and getting this solution is correct. I am not quite sure, but I find it is not correct, but because the problem is here theta is varying. Okay, so this is how you can arrive at the solution for this problem. I think this has no ambiguity, and the students will be able to clearly understand this solution using this method. Okay, so we'll go to that. I think we'll see the next problem in the other video because I have some constraint in the time for the video. So I'll post it in the next video.